right, so we want to do the graphical approach for 11.2.
If we have to.
Trust me, this is a cool trick. This will make your lives much easier, not harder. Okay, so I want to remember what an inverse function does for a second. So from the idea section or something, I'm going to go ahead and assume that f actually has an inverse, right? That's not always true. If it doesn't pass the horizontal line test, for instance, I couldn't make this statement at all. Cool. All right, so I've got an f and an f inverse. Those undo one another, right? Okay, so if I think about a point on f's graph, so f's graph, right? What do points on there look like? You guys remember this?
X, F of X.
They look like an x, f of x pair, right? Okay, so if f inverse undoes things, right? You guys see that? Then it should,
F of X should be first. Now, do you want to inverse?
No, F minus 1 X would be
No.
first.
see, so what I'm thinking, right, is if f undoes things, there should be some kind of a nice relationship here, right? You guys see that? So if I think about one of these points being something like 2, 1, for example, right? This says f takes 2 to 1, right? What does f inverse do?
Takes 1, 1, 2.
Okay, so f inverse takes the outputs for f and as inputs turns them into the inputs of f.
So
basically
basically
see that?
swap the coordinates.
Yeah, so it's going to swap the coordinates, but it's also going to swap their places. You guys see that? So my graph for f inverse, right? F inverse's graph is going to look like f of x, right? If I input f of x, I get x back out.
Right.
You guys see that? Okay, so this gives me a scheme for drawing the graphs of inverse functions.
They'll be parallel.
They're kind of a weird relationship, right? I need to swap the x's and the y's. You guys see that's exactly what we did here? So this thing kind of takes the y values and puts them into the new x's, and this takes the x values and puts them into the new y's, right?
So,
Cool with this? So this is what the glass is for. So let me draw some coordinate axes here. So here's some coordinate axes, right? Okay,
oh, you should press them in one more time just to be sure.
they're good.
Okay.
This one's the weak one, by the way.
I can tell.
Yeah, less than 15 minutes on that one. The other one seems to last forever, so that's good. All right, so I want to invert some function. So let me start with a function I know has an inverse, like x cubed. That's a good one because I'll recognize the graph of the inverse function, right? Okay, so here's more or less f of x is x cubed, right? Okay, now I'm going to need a camera stop. Now I want to swap the x's and the y's, right?
Like,
You guys see that? So these were the x's, those were the y's, right? To get the graph, I need to switch those.
could you just put it outside?
You want to grab the other side of that? and we're going like this. You guys see that?
Mm-hmm.
We're gonna have to hold it up.
That's the same.
Is it?
No, it's not. It's not the same.
You guys see what happened? I just swapped the labels on the X and Y axis.
Oh
So
my
now
gosh.
these are the old Y's, right? Which should be the new X's. These are the old
Could you,
X's, right? There's my X. But those are the Y's. You guys see that?
could you do the same by just like taking your picture and turning it on its side and then like mentally picturing?
Let's try it. Okay, so here's our picture, right? We want to turn it on the side.
Yeah.
So, like that.
That is not the same.
Why is it not the same?
Because it's in the negatives.
Yeah, because you pointed the axis that way, and it needs to be pointed this way. So it needs a rotate and a flip.
Oh, like you learned that in like Algebra 1, don't you?
Yeah,
About the flippies.
maybe. Yeah. So what's happening here? What are we rotating around? You guys see it? It's not the axes. We're swapping the axes, right? Here, let's put it back and let them figure out what we rotated.
Let them figure
Got it. Thanks. Okay, so we started with this, right?
I'll be flipping this way and then turning it that way.
And in the end, we ended up with something that looked like this, right? You guys see that? So there was a rotate and a flip, or just a flip around.
0.
Gotta flip around the line. You can't flip around a point.
So yeah, you would flip it down and
Is it just flip down?
then. No, you flip it and then.
Yeah, it's a flip and a twist, right? I claim it's just a flip around something. Somebody want to come up here and play with it? See if we can get it to twist.
I like the picture as it is now.
Looks like
It's not just flip this way.
Wait a minute.
Oh yeah, come here, show them. Come on, show them.
What's 0 on the graph called?
She figured it out. It's the origin.
Oh. Well, isn't it the
You
orange?
guys
I'm
see?
not sure about that.
Yeah?
Like that.
You guys see what we did?
And then
We grabbed the corner. Because a piece of glass isn't square, it didn't quite work, right? But what does the corner roughly correspond to? Here, I got it.
Okay.
are they called planes?
You guys see what we did? We grabbed it at the corner. We really wanted to grab it here and here. You guys see that twist? If you grab by those 2 points and just flip the glass over. So we're rotating around. Markers suck.
Oh, that was so
Not very close. Thanks though.
There's a pretty pen.
So we're rotating around the line.
We're rotating around a line. What line is that?
B line.
What's the line that should stay the same when you swap the X's and Y's?
The actual answer. The linear.
How about what's this point?
The intercept.
Where's cube root of X and cubing do the same thing? How about what's the number that you raise to a power you get itself back? 1. Right? That's 1, 1. Okay, see that? The cube root of 1 is 1 and 1 cubed is 1. So it should be invariant, right? It should be common under these. You guys see that it doesn't matter when I switch the X and Y's for 1, 1?
So why is it inverse?
It's an inverse because of this, right?
Okay.
So what am I flipping around? What are the things that stay the same when I swap the X's and Y's?
points. One, very constant.
Points that look like number, right? What's that the graph of?
A line.
That looks like.
It's the graph of the line y equals x.
Oh, that's so
You
pretty.
guys see that? That's where the x and y values are the same. So when I swap them, I get the same points back. You guys see that? So when you want to get the graph of an inverse function, you can graph the function you know, and then just rotate around y equals x. This is hard to do with a piece of paper. Why?
Because you can't see the other side.
Yeah, because you can't see the other side. When you rotate, your writing's on the opposite side.
Would it help to do it with like a really, really thin paper?
Yeah, or hold it up.
Yeah.
Yeah, that gets to be a nice way to do it, actually. The piece of glass is another option, right? But less effective on tests.
So we know about the test.
You may bring a small piece of plexiglass if you want to play.
Can you
It
like?
cannot be this size. I don't want you to hit your neighbor with it.
Give it a test. Cut the express.
Do we get extra credit if we bring a picture though?
Well, you probably get the problems right more often. That's kind of like extra credit. Did you have a question, Jasper?
Yeah, so what's a practical way to, I guess, turn in, flip it or whatever without getting confused when you don't have.
Yeah, without a big piece of glass?
Yeah, because that seems like could be really easy to mess that up.
Okay, so if I want to flip something over, right? We could really play this game all day. This is fun. So if I wanted to flip over like the line that I had before, 2x plus 1, can I graph that? So I'm looking for f of x is 2x plus 1, right?
Yeah.
Okay, so can I graph this thing?
Yeah.
Okay, how do I start?
With a line.
X is your F of X.
Don't bother making a table for this. It's a line. You know what it looks like.
That's one.
Just start at one and then you go up to
Number
one.
one.
Okay, so we start at the y-intercept, right? 0, 1.
Up two.
And then we go over 1, up 2. So looks like I picked about that as my tick distance. So here's my kind of other point, right? And maybe if I got one more, that'd be a good idea. So there's my line, right? Now I want to flip over y equals x to get the graph of the inverse function. So I should kind of carefully graph y equals x, right? Now I want to think about flip this over, right?
Flip one over, is it 2x plus 1 or?
I want to flip the black over the purple. You guys see that? So, let me see. Let's try another color. This point's going to stay fixed, right? Because it's on both lines. Okay, so that guy stays fixed. And then, let me think. So, to flip this over, I should make about that distance off this side, right? You see that?
Why are we doing that? That's 2?
I'm just trying to flip the picture over, right?
Okay.
So if I put this line on the other side, right? If I think about take this picture and spin it, I need to get this distance the same.
Okay.
This distance should be the same, so I can kind of eyeball these guys, right? Then this distance should be the same. Then I really just need to connect the dots, right? Even rotated, this is going to be a line.
So is the constant always going to be 1, 1?
Is the constant going to be what?
Is it always going to be 1, 1 the coordinates? The negative 1, 1?
That just happened to be on this one.
Oh,
That's going to be wherever the line that you're drawing hits y equals x. Which it won't all the time, right? If your line has slope 1
Yeah.
but is up or something, then when you flip it over, it'll just be down.
Okay.
You guys see this?
Do you have to say what direction you
No, you flip it over y equals x. You do that all the time.
Can't we just find the inverse of the actual problem and then just graph that? Or
Sure.
does that not work?
That would also work.
Okay.
Cool. Do you guys want to see why we can't invert a parabola?
But you,
That's when I can maybe, oh, I shouldn't have taken that thing.
Oh, you said because it's,
Yeah, it's not 1-to-1, right?
yeah.
Okay, so we should be able to see it in the picture. Hang on, 1 second. Okay, so here's my picture, right? I need to get my stuff off my glass. This isn't going to be good. I need an assistant. Somebody? Anybody? Come on.
It's gonna be you.
Cameron? Just flipped. Okay, so I want x squared, right? So that looks roughly like this. Just buy into that. Okay, now I want to rotate around y equals x. So we spin.
and make a C.
We make the C shape. What's wrong with the C shape?
Can't do that.
It's not a graph.
It's not a function, right? It's not the graph of a function. Why? Because it fails the vertical line test, right? You guys see that? So the horizontal line test is as simple as, hey, if it fails the horizontal line test, when you flip it over, it's going to fail a vertical line test. You guys see that? There's nothing else there. Cool? All right, so this is the approach for graphing functions. We'll set it down. Thanks, Cameron. Cool? Graphical approach. Flip over the line y equals x. That'll get you the graph of the inverse function. Cool?
So again, the odds work and the negative evens.
Yeah, so again, the x to an odd power functions, those will all have an inverse because they're 1-to-1. I can do the flip and I still get a graph that passes the vertical line test. With the even ones, they go kind of up in both sides, right? So if I flip them over, they're going to go kind of this way in both sides and they're going to fail the vertical line test. Or the inverse function would. The thing I want to be an inverse function, right? It's going to fail the vertical line test, so it's not going to be a function. Cool?